Hi, everyone. This is the final segment of Lecture 21. So far, we've talked about the moons in our solar system, ones we think are particularly exciting as places where we might look for life. And now, in this segment, I'm going to talk about future missions to look for life or to assess the habitability in more detail on a few of these on a few of these moons. So this is a look towards what's going to happen in the next decade or two, and we're really excited to see what these new spacecraft are going to tell us about what's going on these very interesting moons. So we can always do remote sensing of these moons from Earth, but it's just really hard to do this. We're far away, our instruments are limited, we can only look at light, we can't necessarily actually do experiments on the material that we see. So it's always better, we can always learn more by going closer to these places and actually taking measurements where they are. So this is again the trade-off between the ease and convenience of remote sensing versus the ability to actually do so much more science in situ. So the first mission that I'm going to talk about is called the Europa Clipper mission. So the Europa Clipper is going to be a spacecraft that orbits Jupiter and is focused on studying the geology and the properties of Europa, the moon. So Europa Clipper will not land on Europa. So a lot of what it does will be remote sensing, but there will be some in situ measurements as well. The goal is to understand, as I said, the geology, the interior, and the habitability of Europa. It's expected to launch in 2024, and it'll take several years to get there, so it will arrive by 2030 or so, we think. And it carries a wide suite of instruments such as cameras, spectrometers to understand what materials it sees, radar to search and understand what's going on underneath the ice of the moon, and a magnetometer to understand the magnetic field of the moon, and therefore to figure out whether there's conductive material like salt water moving around underneath the surface. And I'm going to show a video produced by NASA explaining the science of the Europa Clipper and explaining what they're going to learn and why it's important.
Europa is the most likely place to find life in our solar system today because we think there's a liquid water ocean beneath its surface. Now we know that on Earth, everywhere that there's water, we find life. So could Europa have the ingredients to support life?
We might be actually looking at a body that is presently alive, presently active, and presently undergoing its geology. There is too much evidence right now lying around on the surface, the red stuff, that suggests that something's going on there. Is that an environment that is habitable for any sort of life form? By golly, we really have got to go back and figure that out.
We have designed the Europa mission to take a spacecraft and its set of instruments all the way from planet Earth to Jupiter.
Previous mission concepts were for a spacecraft that would orbit Europa, but Europa is bathed in radiation from Jupiter. Any mission that goes in the vicinity of Europa is cooked pretty quickly. Instead, we're looking at a mission that will orbit Jupiter, make close flybys of Europa, and then zip out of the high radiation region.
Kind of like when I was a kid, we had the sprinklers, and we didn't want to be too close to the sprinkler head, so we would run in and get a little water and then run back out again.
This allows us to have a mission that's many years long and to collect and transmit lots and lots of data. As Europa orbits Jupiter, it flexes, and we could measure the gravitational change of Europa by encountering Europa at different points in its orbit. On a typical flyby, we would turn on our remote sensing instruments, we would image the surface, we would interrogate the surface with spectroscopy, and we would do the same thing on the way out. And we would essentially rinse and repeat and do this many, many times until we understand Europa globally. Images from the Hubble Space Telescope tells us that Europa might be erupting plumes of water high into space. If that's true, then we could fly through those plumes with a spacecraft and literally taste it to understand the composition of Europa's interior.
If it does have the ability to harbor life, how does that work exactly? We'll have enough instrumentation to really pinpoint exactly how the mechanisms would work for replenishing the nutrients in a subsurface ocean.
Europa is so important because we want to understand, are we alone in the cosmos? If there's life in Europa, it almost certainly was completely independent from the origin of life on Earth. That would mean the origin of life must be pretty easy throughout the galaxy and beyond.
Okay, now that we've seen this video, let's move on to the next mission. This one is called the Dragonfly mission, which is going to Titan, which is one of the moons of Saturn. This mission is totally wild and sounds very sci-fi, but it turns out it's actually doable. So unlike the Europa Clipper mission, Titan is designed to actually land, the Dragonfly mission is actually designed to land on the surface of Titan. But it's not your typical planetary rover where you land and then you drive around with wheels. In fact, it's a helicopter. So here's an animation produced by NASA showing what Dragonfly would look like and how it would originally land. So this parachute has been deployed from space. It's essentially fallen down from the top of the atmosphere, deployed a parachute to slow it down. And then when it finishes with the parachute, instead of just lowering gently onto the ground, it just flies off. It turns on its helicopter rotors. And the helicopter aspect makes it very easy for it to move around and look at different parts of Titan. So building a helicopter on another planet seems totally crazy, but Titan's actually a pretty good place to do it because Titan has a thick atmosphere, so you don't need particularly large rotors to generate a large amount of thrust. There's a lot of air to push around. And Titan has relatively low gravity because it's a moon and therefore doesn't have as much mass as a planet like the Earth, and it's easier for you to lift something off of its surface. So this is a really exciting mission because it will be able to do all sorts of new science and make measurements and learn about what is actually on Titan, what molecules, what evidence there might be for life in many different locations, flying around. So here are some key characteristics of the Dragonfly spacecraft. As I said earlier, its goal is to understand the geology, the weather, and the presence of life on Titan. It's a little bit further off. It'll probably launch in the late 2020s, so maybe 2027. And then it'll take it about 10 years to actually fly from Earth to Saturn to get there. Once it arrives, it will use instruments like a mass spectrometer, which tells you what different compounds that you ingest into your spectrometer. So like actually making measurements of what molecules and what atoms you see on the surface are made of. It has a neutron gun, which will shoot neutrons at samples underneath the helicopter, and it'll have a spectrometer to interpret the results with gamma ray light. That'll be another way it can determine what elements it's looking at. It has weather monitoring equipment, so essentially a big weather station where you can measure atmospheric pressure, temperature, wind speed, humidity. Although in this case, when we're talking about humidity, we're not talking about water humidity, we're talking about methane humidity, because methane plays the same role as water in the atmosphere of Titan as water does on Earth. And it has a seismograph, so it can search for earthquakes, or I guess in this case, Titan quakes, and understand what's going on underneath the surface based on how the waves from the different earthquakes or Titan quakes pass through the material. And finally, it will have a suite of cameras that it can use to take images of Titan. It will be able to fly. It will have a range of about 50 kilometers in one hop. It will have a battery that charges it up and gets it ready to fly. And then it'll use that flight time of about 2 hours to travel up to 50 kilometers before it makes a new jump. So you can really cover a lot of distance if you do that. And the really amazing thing about Dragonfly is that its power usage is only about 70 watts. So that's how much power it can generate from its nuclear batteries. And that 70 watt amount of power is less than a single incandescent light bulb used. So this is a really amazing spacecraft, which is built into some incredible constraints and should be able to do amazing things. It'll be really exciting to see how it works. And I will leave you with this NASA animation, which describes the science of Dragonfly.
Saturn's largest moon, Titan, has a thick atmosphere and a frozen surface rich in organic molecules. In 2034, a NASA mission called Dragonfly will arrive at Titan and study its chemical makeup. Dragonfly is a rotorcraft designed to visit multiple sites across the moon's varied terrain. At each new landing site on Titan's surface, Dragonfly uses a pulsed neutron generator and onboard gamma-ray sensor to detect key elements such as carbon and hydrogen in organic materials or oxygen in water ice. Dragonfly determines if there are well-defined layers of these materials just below the lander. For a closer inspection, Dragonfly uses its drill to generate tailings from Titan's hard, frozen surface. These surface samples can then be ingested through the pneumatic system, carried with Titan air into the chilled sample lines and to the sample collection carousel. One of the carousel sample cups is placed in a pneumatic port. The cup captures the surface material from the cold air stream and transfers it to the chemical laboratory for measurement. Pulses from a laser release large organic molecules from the surface sample for analysis in the mass spectrometer. The mass spectrometer sorts molecules by mass and measures diagnostic fragments that tell Dragonfly the kinds of chemical components that are present in the surface and whether there are molecules of prebiotic interest. For those potential prebiotic samples, a new cup is placed into an oven and heated to release molecules into a gas chromatograph, where they are sorted for size and type before entering the mass spectrometer. This advanced separation of organic components includes isolating molecules with the same formula but different chiral arrangements, or handedness. Having a preference for one-handedness over another is a key biosignature for life on Earth. When the chemical analysis is complete, Dragonfly may choose to take another surface sample or find a new location on Titan to investigate.